This question appeared on a video that was answering a different question about Excel VBA. I slightly feel like I've let myself in for question inception at this point by starting this answers series. I suspect that every answer I give is going to spawn more and more questions, but hey, that's okay. I will do my best to answer as many as possible. I can't promise a video answer for everything. My list is long and my time is short, but I will do my best. Anyway, onto the specific question that was asked. What Neil wanted to know was why we write an if statement in a particular way, why this double negative of if not, something is nothing. It's a pretty simple question to ask, but a slightly trickier one to answer, as you can probably judge by the length of the response I've written. It turned into a slightly more of an essay than I intended, and sometimes it's just better to show than it is to tell. Now, I appreciate when we're getting into some of the more detailed topics in our Excel VBA videos, we don't get a chance to explain the basic stuff that we're doing. But there's never a bad time to revisit the fundamentals as far as I'm concerned, hence this video. So we'll have a look at how we can write if statements in a variety of ways and why we need to write some if statements in a particular way. I started with a blank Excel workbook and typed in a positive number in cell A1, a negative number in cell A2, and any old random bit of text in cell A3. I also added a second worksheet, although there's nothing in there now, that's for later on in the video. In the VB editor, I've created a new module and started a new subroutine called VBA Logic. A logical statement in VBA is one which returns the value true or false, or a Boolean value, in other words. If you've ever wondered why it's called Boolean, by the way, it's all to do with the work of George Boole, the mathematician, so now you know. So the simplest logical statement we can make in VBA, let's try to specify whether cell A1 is greater than 0. So I'm going to make the statement, range A1 dot value is greater than 0. Now that statement by itself wouldn't actually do anything in VBA. You can see you get a syntax error when you move away from that line. So I need to return the value from that statement somehow. A nice simple way to do that is to debug.print it. So if I say debug.print the result of that logical test, when I run that, range A1's value is indeed greater than 0, so that returns true. If I change that to range A2 instead, range A2 has the negative number in it, so that is not greater than 0. I return the value false. And if I refer to range A3, which has some bit of text in it, that is returned as true, so apparently inception is indeed greater than 0. Now, it's quite rare in VBA to make use of logical statements in quite so simple a fashion. Ordinarily, you'd include these logical statements as part of an if statement to perform different actions based on whether the result of that condition was true. So let's change our debug.print statement into an if statement. The next part is optional. You don't have to, but you may prefer to wrap your logical test in a set of parentheses just to make it a little easier to see the individual logical test or the Boolean statement. And then at the end of that, I can write the word then, and let's print out a slightly more descriptive message. I'll say debug.print, and I'll just say value is greater than 0. Of course, if that condition wasn't true, we could write the word else to deal with the false part of the if statement. So we could copy and paste our debug.print statement and say something simple like value is not greater than 0, and then say end if to complete the block if. Now remember that our logical test returned a value. It returned the value either true or false. So the more complete way to state this if statement would be to say if that logical test equals true. It's quite rare to see it written out in quite so complete a fashion, but it does work. So if I were to run this subroutine for cell A3, which has the word inception in it, it says value is greater than 0. If I run it for cell A2, that is not greater than 0. And back for cell A1, it is greater than 0. As I say, it's not usual to see the equals true part of this. Normally, you simply see the logical statement if A1.value is greater than 0. That implicitly means is the result of that condition equal to true. So with A1, I can run that again, it says it's greater than 0, and with A2 I can run it again, and it's not greater than 0. Okay, now let's say we wanted to reverse the logic of our if statement. We wanted to check if the value of the cell was not greater than 0. We have a few choices, and if you were trying to do this in the easiest way possible in the real world, rather than trying to describe how logic works in a video, then you'd simply change the comparison operator from greater than to less than or equal to. If it's less than or equal to 0, it is implicitly not greater than 0, and that would work. But I want to keep my comparison operator the same. I want it to say greater than 0. And if I wanted to do that, I've got two choices for how I could check if that statement returns false. I could either say equals false at the end, write out the complete test as we saw earlier on for true. I then just need to flip the logic of my actual answer statements by replacing the word not, or flipping the word not in between those two statements. Let me just clear the contents of the immediate window as well, just so we can see a clean run of this. So if I'm looking at cell A2, I'm asking if A2's value is greater than 0 equals false. Then that must be not greater than 0. It's all getting a bit confusing at this point already, isn't it? So value is not greater than 0. If I refer to cell A1, then I run that one, the value is greater than 0. So that statement, range A1.value greater than 0. That portion returns true. Then I ask, is true equal to false? No, it clearly isn't. So it jumps into the else part of the if statement and prints that value instead. Now, rather than writing out a full logical test like this and asking if this logical test equals false, we can write a slightly more succinct version of this by taking away equals false, and then at the beginning of the logical statement, before the parentheses, say not. So this does exactly the same thing. If I check if not range A1.value is greater than 0, so this part returns true because range A1 is greater than 0. Then I use the not keyword to reverse the logic, or change true to false, or vice versa. So that will result in false. So because that results in false, I jump into the else clause of the if statement and print out the value is greater than 0. So when I run this, value is greater than 0. If I refer to cell A2, then this portion of the statement, range A2.value is greater than 0. That's false. Not changes the false to a true, so this entire portion of the statement returns true. So if true, then print out this statement. So when I run this one now, it prints out the value is not greater than 0. Now, if you're sitting there thinking that this is a very silly and confusing way to ask a very simple question, I completely agree with you. Why on earth would you confuse yourself by reversing the logic of this simple statement when you could omit the not keyword entirely and just go back to your original question, if the value of the cell is greater than 0, remembering that this is the same as saying if this logical test equals true, then say that it is greater than 0. Otherwise, say that it's not greater than 0. That would make far more sense, and that is exactly what you would do in the real world if that was the test you were trying to perform. But the ability to reverse the logic of a statement is quite an important one, and you will make use of it when writing code in VBA. But it comes in more handy when you start using functions which can potentially return Boolean values. Just to demonstrate that, I'm going to comment out my entire if statement, and then I'm going to revert to just printing out the value true or false by testing if the value in a cell is a number or not. So I'm going to say debug.print, and then I'll look for the isNumeric function. When I open the round brackets after isNumeric, you may be able to make out in the tooltip there that the function returns its result as Boolean, so it can only possibly return true or false. So I'm going to say range A1.value and then close the round brackets. Range A1 definitely has a number in it, so if I run that subroutine, it prints out the value true. If I refer to range A3 instead and run that subroutine again, it then prints out the value false. Now let's make use of that function in our if statement. I'll just uncomment all the code from my if statement again, and then I'm going to copy my entire isNumeric function and place that inside the parentheses on our if statement line. So if isNumeric range a3.value, then print something. I'll just comment out the debug.print statement I was using. I may use that again later on. And then I'm going to say, so if the value of the cell is a number, I'll say value is a number. And then otherwise the value is not a number. So if I refer to cell A3, that will say in the immediate window, value is not a number. If I refer to cell A1, then it is a number. And remember that what we're doing here, this logical test in the parentheses, we're essentially saying in a shorthand fashion, if this condition equals true. So adding equals true to the end is not necessary. It does exactly the same thing with the equals true as without, but it helps to think of what's actually going on if you always imagine that equals true at the end of your statement. Now let's imagine that in this subroutine, all you cared about were the cells which did not contain a number. So for example, you might be writing a validation subroutine to check that the user has entered a number into a cell before the rest of your code proceeds. At the moment, our if statement is a little sort of inefficiently written, or inelegantly written at least. We've checked, is the value a number? I don't care about doing anything. If it is a number, I don't want to do anything at all. I don't care. Great. If it's a number, superb. If it isn't a number, however, so if we get into the else part, then we can say it's not a number and then whatever validation procedure we want to execute. But it seems silly to have an else clause for this. So what we could do instead is remove the else clause and then reverse the logic of our if statement. We could say if isNumeric equals false. If I could spell false, that would help. There we go. Let me just clear the contents of the immediate window just to tidy up a little. So if isNumeric equals false, then I get my validation message. So if I run that one, value is not a number. If I refer to cell A1 or A2, those are both numbers. So I don't get my validation message, nothing happens. Again, the alternative way to write this, rather than adding equals false to the end, is to add the not keyword to the beginning of the logical test. So if not isNumeric, then do this thing. Same result if I have cell A1 referenced, then nothing happens. But if I refer to cell A3 instead and run that again, I get value is not a number. So hopefully you can see that using the not operator makes writing certain if statements that bit more compact and elegant, particularly when you're using the results of functions. For the next little section, I want to talk about how we compare objects in VBA. So far we've been comparing simple values. So we've been looking at numbers, Boolean values. We could have been looking at bits of text, or we could have been looking at dates. But all those items, all those variables, if you will, are value types. They're just a single, simple bit of information held in memory. When you're comparing objects in VBA, what you're doing really is comparing reference types. And when you want to compare reference types, the rules about how you do that are a little bit different. So I'm just going to comment out my if statement first of all, and then I'd like to write a new if statement that compares the active sheet with a particular worksheet, either sheet 1 or sheet 2. Let's go for sheet 1. So I'm going to write an if statement. I'm going to say if the active sheet, and I want to check if the active sheet is equal to sheet 1. Now, what you might be tempted to do when you first start doing this is use the standard equals operator. But this isn't going to work. Let me just show you that. I can reference sheet 1 in a couple of ways. I could reference it using its code name. So from the IntelliSense, I could refer to its code name, sheet 1. Or I could spell out the full way of referencing the worksheet using the worksheet's property. And you can see here, hopefully, that the worksheet's property, a little like the isNumeric function, has a return type. The worksheet's property returns a reference to an object. So worksheets, sheet 1, and then I'll say then. I'll have my else and my end if as well. If I could spell if, that would help. And now let's just have a couple of simple debug.print statements. So I'll say debug.print sheet 1 is active, and then just copy that to the else clause and say sheet 1 is not active. Okay, so it looks sensible. There are no syntax errors there. But if I attempt to run that subroutine, it fails. Object doesn't support this property or method. If I hit debug, it's the if statement that's failing. That's because when you're comparing reference types, the standard comparison operators don't work that same way. If I want to check if the active sheet is sheet 1, then I need to use the special is keyword. So you use the is keyword to compare reference types in VBA. And if I have sheet 1 active when I run this subroutine, it tells me sheet 1 is active. If I select sheet 2 to make that active and then run the subroutine again, sheet 1 is not active. Now, if you think back to the way our basic logic works, this if statement we've written here could be expanded by wrapping this logical test in a set of parentheses, again that's optional, and then asking if the result of that logical test equals true. So having done that, if I run the subroutine with sheet 2 selected or active, sheet 1 is not active. If I switch back to sheet 1, run the subroutine again, sheet 1 is active. So what if I wanted to reverse this logic? What if I wanted to do something special if sheet 1 was not the active sheet? I don't care if sheet 1 is active, I don't want to do anything, but if sheet 1 is not active, then something must happen. At the moment, the way we've structured our if statement, we've got this slightly inelegant solution again, where we would have to use the else clause to process the not sheet 1 object. So instead, what we could do is change this keyword here from true to false, and then we could remove the else clause. So as long as sheet 1 is not active, or if the active sheet is sheet 1 returns false, then sheet 1 is not active. So when I run this one this time, let me just clear the contents of the immediate window to make it a little easier to see. So sheet 1 is active at the moment. It says nothing at all. I don't care. Sheet 1's active, so what? Nothing needs to happen. But if I don't have sheet 1 active, when I run this subroutine, I do indeed see something. Again, this is really just a matter of preference. If you like writing your if statements like so and asking if this is equals false, then fine, no problem at all. But you may consider using the not keyword at the beginning of the logical test instead. Some people prefer that style if not this condition. And again, if I run this one, sheet 1 is not active when I don't have sheet 1 active, and then nothing at all happens when sheet 1 is active. Now the is and the not keywords become even more useful when you start using functions which return references to objects rather than just simple values. As a quick example, I'd like to look for the word inception within cells A1 to A3 and then say what should happen if the word inception does not exist. To do that, I'm going to use the find method. So I'm going to comment out this if statement here in its entirety. And then to begin with, the basics of the find method, I need to refer to the range in which I'm looking, first of all. So I'm going to say in range A1 to A3, I want to use the find method. If I open up some round brackets or parentheses, you can hopefully see that the find method returns a reference to a range. I'm going to specify that I want to look for the word inception in that list. And then I need to know what happens if the find method doesn't return a reference to something. What if it can't find what it's looking for? A nice easy way to spot that is to click on the word find and then press the F1 key on the keyboard to launch the context-sensitive help system. That takes me to the range find method, tells me what it does and what type of thing it returns. The interesting part here, if I scroll down far enough, is in the remarks, which says this method returns nothing if no match is found. Now the word nothing there is highlighted in bold. The word nothing is a special keyword in VBA, which represents a reference type which doesn't reference anything. So just to show you, put that into plain English and show you how you can use it, if I switch back to the Visual Basic Editor, I could say if Then I'm going to wrap this logical test in some round brackets. So if range A1 to A3.findInception is nothing, then, and don't let me forget to close the parentheses there, I can then add my end if statement. And then I could say something like debug.print inception has not been found, something along those lines. All right, now remember this logical test is the same as the slightly longer, more expanded version where you can say if the result of that logical test equals true. So if I have a quick look, the word inception does exist within range A1 to A3. So if I run that subroutine, nothing will happen. If I perhaps updated my cell references, let's say let's look in cells B1 to B3 for the word inception, which clearly is not there. If I run that, it says inception has not been found. So again, what happens if you wanted to reverse the logic of that expression? What if you only wanted to do something if finding inception doesn't return nothing? So we've got a couple of choices yet again. If looking for inception is nothing equals false, then we can say, no, inception has been found, or go and watch it, because it's fantastic, it's a great movie. So there we go, watch it. And then if I look in cells B1 to B3, nothing will happen because inception is not in that list. But if I look in cells A1 to A3 and run that again, I've got to go and watch it now. No problem with that, it's a great movie. Again, if you don't like this tagged on equals false at the end of your logical test, we can replace the equals false with the keyword not at the beginning. So if not, range A1 to A3.findInception is nothing, i.e. if inception has been found, then we can go and watch it. So at this point, I think we finally have enough information to answer the original question. And just because I can barely remember that far back, sorry it took quite so long to get to this point, the original question was, why do we write if not Application.Intersect is nothing? So the question was asked on a video that was essentially trying to check whether a user had clicked somewhere within a particular range of cells. And the Application.Intersect method allows you to check for that. So just going back to the VB editor, let's change, in fact, let's write a new if statement. Let's comment this one out and write another new one just down below. I want to check if Application.Intersect, and if I open up the round brackets there, you can see quite a long list of arguments, up to 30 of them in fact, but the end result is that the intersect method returns a reference to a range object. So no matter how many different ranges of cells you reference within the intersect method, if any of those cells overlap, the intersect method returns a reference to that range. If none of the cells overlap, then the intersect method returns nothing. So for example, let's try to check in this system whether we've clicked in a cell within cells A1 to A3. So in the intersect method, we could say range A1 to A3. And then the second argument will check if the active cell overlaps that range. I then want to check if that is nothing. So let's say is nothing. Then a couple of blank lines and then say end if. So at the moment, again, if I just wrap this logical test in a set of parentheses, this is going to trigger our code if we've clicked outside of cells A1 to A3. So a quick debug.print statement outside A1 to A3. Okay, if I then do indeed click outside cells A1 to A3 and then run this subroutine, we are indeed outside that range of cells. If I click within that block of cells and run the subroutine again, absolutely nothing happens. So I basically want to do the opposite of that. Again, we have those same two choices. We can either add equals false to the end of our logical test and then do something because we know that we are inside that range of cells. Alternatively, we can do this slightly more compact, slightly more elegant approach, where we take away the equals false at the end and add on the not operator to the beginning of the logical test, so that when we're inside A1 to A3, we get our actions being performed. So there we go, that's why we write if not Application.Intersect is nothing. Basically, we want to do something if we have selected a cell within a certain range. I'm not entirely sure at this point, I have to admit, whether I've made things better or worse with such a long-winded explanation. Hopefully better, and hopefully it's cleared up a few of the mysteries about why we write if statements in a particular way. I'm sure somebody will ask me another question that gives me an opportunity to go off on a long rambling answer again, so I hope you're looking forward to that. Until then, thanks for watching, see you next time.